Hello, ladies and gentlemen. Welcome to Vodcast number 9 in our Vodcast series, in which we review each of the units that we've had all year, and then you can use them later on in the year to help you review for the final exam. So this podcast is about Unit 9, and hopefully you remember what Unit 9 in geometry is about. It is about area. So for each of the screens that you're going to see, we are going to review each of the formulas for the different shapes in geometry, and if you don't remember them or you have questions about them, you should write them down so you can study them and ask me questions later on in the day or before the test. So here we go. So the first shape is a rectangle, and I hope that you all remember the basic formula for the area of a rectangle, which is area equals base times height. Where did it go? Sometimes you might have heard also called length times width. Either one works fine. Our second shape is a parallelogram, and a parallelogram actually has the same formula as a rectangle. The difference is that the height of the parallelogram can actually be outside of the parallelogram, like this one over here. So you have to remember that sometimes the height is not inside the shape. Our next shape is a rhombus. A rhombus is actually a special type of parallelogram, which means you could use the parallelogram formula that you saw on the previous slide, or you can use this special formula, which is area equals 1/2 times diagonal 1 times diagonal 2. And you could find the lengths of the diagonals possibly by doing some Pythagorean theorem work, because the diagonals of a rhombus intersect at a right angle. Okay, next shape is a kite. And a kite is similar to a rhombus in the sense that it has right angles in the middle, but the diagonals do not bisect each other, so you have to deal with them a little bit differently. Ironically, though, you can use the same formula for the area of a kite as you do for a rhombus, and that area is 1/2 diagonal 1 times diagonal 2. You could also break this shape into different triangles. There is this triangle on the left, which happens to be the same shape as the triangle below. There is also this triangle to the right. Whoops. Let's fix that guy. There's also this triangle on the right, which happens to be the same as the triangle below it as well. Or you could also think of it as two large triangles. There's one on the top, one on the bottom, one on the left, and one on the right. Lots of choices. So this is a trapezoid, and a trapezoid could actually be broken into a rectangle and two triangles, or you can use the special formula that we have for a trapezoid, which is the height of the trapezoid times base 1 plus base 2, and that whole thing divided by 2. Again, you could break this into a rectangle and two triangles as well. Our next shape is a regular polygon, and remember that a regular polygon is a shape that has all sides equal and all angles equal. So the one that you see here on the left is a regular hexagon, because all of the sides are the same. And the one on the right happens to be an octagon, but this works for any polygon in which all of the sides are the same. And the formula for the area of a regular polygon is 1/2 perimeter times apothem. If you do not remember what the apothem is, you need to go look that word up, because that one will be asked on the test. Next is a triangle, and I know that you remember the basic formula for the area of a triangle, which is 1/2 base times height. But the other one that we learned in this unit is new to this unit, and it is 1/2 a times b times sine of c, where a and b are two sides of the triangle, and c is the angle in the middle. So a, b, angle C in the middle. Next shape is a circle. This one, again, I know you know from previous classes, and its area equals pi r squared. And you know a lot of times we write the pi on the other side of the r squared. Now we have the area of a sector. A sector is really just what I like to think of as a piece of pie or a piece of pizza, and you're finding the area of that. And it really is just a proportion or a portion of the circle. So you have n over 360 times pi r squared. Pi r squared is the area of a circle, N is the number of degrees in the center of the circle that is making up the sector out of a total of 360. Finally, we have the area of a segment, and a segment is really just a piece of a pizza crust that you would think of cutting off when you are baking a pizza. And the formula for this is really just find the area of the sector, subtract the area of the triangle to get the area of the segment. So here we have the area of the sector. Here is this part, and then the area of a triangle in whichever form you'd like. Please make sure you have copied everything down you need and come back and revisit this if you find it necessary to help you study for the test.